champions, welcome back to the Crash Course, and in today's video we are going to solve the last 10 years of KCET PYQs from the chapter Organic Chemistry, some basic principles and techniques. So now let's do with the first question of 2025. Now let me tell you, this question is directly picked up from NCERT. So the IUPAC name of the given compound is, so we know that there's a lot of confusion whether we have to give preference to double bond, triple bond, whether name will end with YENE or NENE. So here you have to first number it 1, 2, 3, 4, 5 and 6. Okay, so the main chain will be hex. Okay, then we have 1, 3 di-EN and then 5 YNE. So option number 2 is the correct answer here. This example is there in your NCERT book. Next we'll go to question number 2, IUPAC name of the given compound. So here I can write 1, 2, oh just a minute, yeah. So I'll just number it. This is 1, 2, 3 and 4, right? So I will have 1 bromo but 2 ENE, okay, 1 bromo but 2 NE, that is option number A. Next, IUPAC name of the given compound. So 1, 2, 3, 4 and 5, because here carboxylic acid is the preferential functional group. So we will have 4-oxopentanoic acid, that is option number B. Next we'll have question, this question is also from 2025, okay. So among the following, identify the compound which is not an isomer of hexane. So if I have hexane, it is C6H14, right? C6H2N plus 2, so C6H14 is there. Now if you see in this particular structure, 1, 2, 3, 4, 5, 6. 6 carbon are there. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there is no, hydrogen is not complete 14. So this is the correct answer. It is not an isomer because the formula is different. Next, which of the following is not a pair of functional isomers? Okay, so we have here alcohol and ether. This is a functional isomer. NO2 and NH2 and COOH. Okay, let us see this one. So, okay, first let me take the other one. Here we have acid and here we have HC double bond O ester. This is there. Okay, now if you see the second one, C2H5O, C2H5 and C3H7OCH3. Yeah, so this is actually your metamers. Okay, these are not functional isomers. So option number D is the correct answer. Okay. Next, identify the correct statement in the following. Dimethyl ether and ethanol are chain isomers. No, they are not chain isomers, they are functional isomers. Ethanoic acid and methyl methanoate are position isomers. No, they are also functional isomers. N-butane and isobutane are functional isomers. No, they are chain isomers. Propane 1-OL and propane 2-OL are position isomers. Yes, option number D is the correct answer. Next, a pair of compounds having the same boiling point are. So we know that in enantiomers we have the same physical properties. So it is plus minus butane 2-OL, which is option number D. Which of the following compound will have possessed the CH bond with the lowest bond dissociation energy? Now if you have this CH bond, okay. Now see, when this CH bond breaks, this carbocation is formed which is highly stabilized with resonance. So that is why this bond will break easily. The answer will be option number C, that is toluene. Next we have CH3 double bond CH2OH with PCC. Hybridization changes involved in carbon 1. So if you see this carbon here is having 4 sigma bond, so it is sp3 hybridized, and this carbon is having 3 sigma bond, so it is sp2 hybridized. So the hybridization is changing from sp3 to sp2, that is option number B. The number of pi bonds and sigma bonds present in naphthalene are respectively. So we have this one naphthalene. Okay, so it is like this. Okay, so now if you see here how many sigma we have, how many sigma and number of pi bonds. So if you see pi bonds 1, 2, 3, 4, 5. So I can eliminate this option. And then I have H also like this. Okay, you need to remember the H values also. Don't forget that. Okay. So how many sigma bonds we are having? 1, 2, 3, 4, 5, 6, 7, 8. Then I have 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. Okay, so 5 and 19, option number B. Next, resonance effect is not observed in. So for resonance we need to have conjugation, right? So here I can, okay, let me start from here. Here if you see this bond, okay, this bond can shift here and then this bond can shift here. So we have resonance here, okay. Now if you see this particular structure, this lone pair can come here, not observed resonance, right? Here also there is no, I can say there is no flow of electrons, so that is why here I think there will be no resonance, okay. Here also you can see chlorine has lone pair, this can come here, this can come here, this can come here and this can go here. So here in option number D there is no resonance. Next, in which of the following homolytic bond fission takes place? So in free radical there is homolytic fission where chlorine bonds break in the first step. Let us see the next question. Carbocation as an intermediate is likely to be formed in the reaction. So here you can see chlorine H nu, this is a free radical reaction, so there is no involvement of carbocation here. Here there is direct addition reaction, no carbocation. Here if you see ethyl bromide aqueous KOH, this is SN2 reaction, so here also no carbocation is formed. But here you can see there is a rearrangement, carbocation is formed, due to which rearrangement also takes place. So option number D is the correct answer. Next, this question was also asked in 2025, okay. Which of the following is not an aromatic compound? So you can see not an aromatic compound. So first one we have cyclic structure, all are sp2 hybridized and there is conjugation. So this is an aromatic compound. Here you can see 1, 2 and we have 1, 2, 3, 4, 5, 6, 4 and plus 2 electron is also there. This is also planar, all are sp2 hybridized and we have 6 pi electrons, so that is also aromatic compound. Next, here you can see we have all of them are in conjugation, planar sp2, so this is also aromatic. Here if you see we have 4 pi electrons, okay, which is not satisfying this 4n plus 2 rule, right? It is anti-aromatic rule, so this is the incorrect option. Option number 4 means this is not aromatic. Option number 4 is the correct answer. A miscible mixture of C6H6 and CHCl3 can be separated by. So what is the method that is used when you have miscible mixture? You can use distillation, okay. Next, during the fusion of an organic compound with sodium, metal, nitrogen of the compound is converted to NaCN, okay. This is during the Tlazine test. So students, these were the top questions from last 10 years. You can see very few questions are asked, so importance of this particular chapter for KCET is less, okay, and so that is why don't go too much in detail. If your organic chemistry for PU2 is fine, you can just go and revise the reactions of PU1, then your chapter will be done, okay. Hello champions, welcome back to the crash course, and in today's video we are going to solve the last 10 years of KCET PYQs for the chapter hydrocarbons. Let's start with the first question, that is, among the following the set which represents the aromatic species are. So you can see one is aromatic, so I can eliminate option number 1 or B and C, okay. Next, option number 2 is also aromatic, so I have that one. Option number 3, this third one is not aromatic because the carbon here is sp3 hybridized, so 3 will not be there, so I have only left with option number D, okay. So 4th is there, 5 is not there because you can see here we have 4n electrons. Now moving to the next one, IUPAC name of the given compound is. So if I want to write the name of this particular compound, I can write 1, 2, 3 and 4, right? So 2,3-dimethyl but 2-ene, 2,3-dimethyl but 2-ene, that is option number A here. Now moving to the next one, the major product obtained when ethanol is heated with excess of concentrated H2SO4 at 443 Kelvin is, okay. So when ethanol is heated at 443 Kelvin, we will have ethene, okay. Dehydration takes place, so option number C here. Next, identify A and B in the given reaction. So I'll just draw this one so that it will be more clear. So I have here propene, okay, and then you are adding HBr with peroxide. Okay, so we know here anti-Markovnikov's rule will be there, so I will get 1 bromopropane, and here I am adding HI, so Markovnikov's rule will be there, and I will get 1 iodopropane, sorry 2 iodopropane. So here this option is incorrect, this option is incorrect, this first one is correct but second one is wrong. Here you can see both are correct, so option number B is the correct answer. Next, arrange benzene, N-hexane and ethine in the decreasing order of their acidic character. So ethine will definitely be highly acidic because it's after it gives H plus, the stability of the conjugate base is very high. After that we have benzene and then we have N-hexane, so option number D here. Next, peroxide effect is observed with the addition of HBr but not with the addition of HI to unsymmetrical alkene because HI bond is stronger than HBr and not cleaved by the free radical. See, HI bond is not stronger, so this is not the correct one. HI bond is weaker than HBr, so that iodine free radical combines to form iodine molecules. Next, bond strength of HI and HBr are not same. Okay, then all of this no. So we have option number B as the correct answer here. HI bond is weaker than HBr bond, so that iodine free radical combine to form iodine molecules. Okay. Next, we have identify X in the following reaction. So here we have benzene with 6Cl2 excess of chlorine. If you will get hexachlorobenzene, that hexachlorocyclohexane, that is option number B here. Okay. Next, we have the alkyl halides required to prepare by Wood's reaction. So here I want to prepare this particular compound. Okay. So what are the compound or what are the reactants I need to have? So first of all, you can see that if I take this one, then I'll get a plain straight chain, right? But I need branched one, so this one will not be the answer. Here I will have 3 branches, that is also not required. Here the number of carbons are less, this will also not work. So if I check this one, okay, so if I have this one, and on this particular carbon you are having 1 carbon and that is also having 2 carbons now, right? So that is what I will get here. So option number C is the correct answer. Next, 2-butene is reduced to trans with sodium liquid ammonia, and if you use hydrogen palladium carbon, you will get cis isomer. Identify the following compound which exhibits geometrical isomerism. So for geometrical isomerism, first of all, but1 ene is not there, but1. So this you need to have a double bond. So that is option number A here. Next, identify the reagent X used for the following reaction. So here we can see H2 and then you are getting cis isomer, right? So for cis we need palladium and carbon. Next, N-propyl chloride reacts with sodium metal in dry ether to give you what? So this one will react to give you hexane. N-propyl will double, so I will get straight away hexane, that is option number A here. Next is toluene reacts with halogen in the presence of iron 3 chloride giving ortho and para halo compounds. The reaction is, so toluene reacts with halogen in presence of iron. So this is your electrophilic substitution reaction, option number D, because toluene behaves as a, so when you take, right, halogen with iron chloride, so if you have like Cl2 in FeCl3, that will give you Cl plus and FeCl4 minus. Okay. Next, I have for the preparation of alkanes, aqueous solution of sodium or potassium salt of carboxylic acid is subjected to. So for the preparation of alkanes, the aqueous solution of sodium and potassium salt of carboxylic acid is subjected to electrolysis, and from that we have the negative ions move towards the anode, positive ions move towards the cathode, and they undergo oxidation, reduction, and we get the alkanes. Next, replacement of Cl in chlorobenzene to give phenol requires drastic condition, but Cl of 2,4-dinitro is readily replaced. This is because NO2 groups makes the ring electron rich. No, NO2 is an electron withdrawing group. It makes the rich deficient, makes the ring electron deficient. Withdraws electron from the meta position. No, it withdraws from ortho and para position. NO2 dominates the electrons at meta position. No, donates. No. NO2 withdraws the electrons from the ortho and para position. Yes, that is option number D. The electrophile that participates in the nitration of benzene, that is your NO2 plus. When you take concentrated HNO3 and concentrated H2SO4, NO2 plus electrophile is produced. Let's see the next question. You have to identify Q in the given reaction. Okay, so we have this COCH3 with PCl3. So what will happen? This one, okay, will the double bond O will be replaced with chlorine, and here I have CH3. Okay. Next, when I do excess of NaNH3, what will happen? This one will do elimination and you will get a product like this. Okay, here HCl will be eliminated, again HCl will be eliminated. So option number D is the correct answer. Okay. Next, the number of possible alkynes with the formula C5H8. Okay, C5H8. Let's draw this first. So I can put here, so I have 1, then 2, 3, 4, 5, 6, 7, 8. This is one possible alkyne. Then I can have in the second carbon, right? So here if I have, that is 1, 2, 3, then I have 4, 5, 6, 7, 8, right? Next I can have is like this, where you can have one carbon like this. So 1, then I have 2, 3, 4, 5, 6, 7, 8. Okay, so I think this 3 is possible. Okay, so option number will be, okay, I can try one more. If I can have like this, okay, then 1, 2, 3, 4, 5, 6, 7, 8, 9. So we require more hydrogen. So 3 is the correct answer, option number A here. Next, sodium ethanoate on heating with soda lime gives X. Electrolysis of aqueous solution of soda ethanoate gives you Y. X and Y respectively are. Now see, when you have sodium ethanoate and you are doing soda lime, that is decarboxylation. So here you will get methane as the product. Okay, and then when you do electrolysis of aqueous solution, it will give you Y. So in electrolysis, 2 radicals will join, you will get ethane. So option number A is the correct answer. Next, but-YNE on reaction with dilute H2SO4 in presence of Hg2 plus at 333 Kelvin gives you. So if I have but-1YNE, okay, and when you react with H plus and H2O, you will get like this. OH double bond C, and now there will be what? There will be this tautomerization, and you will get a compound like this. Okay, that is your butane 2-ONE, which is my option number A. Okay, so students, yes, this was the most important questions from the chapter hydrocarbons, and I hope you have understood the level. It is not that difficult.